Okay, Lady Ada, the thing's live. What is this? What are we doing? What are we doing
We're here at another weekly show and tell here at the Adafruit Factory. We're the hosts, and you are our special guest. And there's Tones. And we're going to call on you in the order in the boxes that like they showed up on our screen.
Yep.
And you can check out our lovely showcase as well. And then when we call on you, just unmute your mic and spend like 5 minutes or 3 to 5 minutes. Because sometimes we get like 4 or 5 more new people during the show, so we might have to compress a little bit.
Right.
Okay, it's going to be Tony, Noah, Scott, Trixabella, Will, and Roberto, and then Roberto's a lizard. And then if you're not presenting, just mute your mic, because otherwise you get feedback. The hosts, and you are like that.
All right.
Okay.
We'll figure out where that's coming from in a moment. There. Okay. Tony,
you're up.
Tony's part of Adafruit West. Show us what you're working on.
Northwest.
Hey, yeah. So not too much of an update on the libraries and porting code right now, but I'll show a quick little project that was just posted on Make Magazine on their blog. I did this maybe about a month ago or so. So I call it the Smart Alarm Clock, and it's an Arduino Yun project. So there's an Arduino Yun and a little TFT LCD shield here, and this is kind of a cheapo knockoff one, but it's nice in that it makes a real little compact unit. And so you can see it looks like just a normal alarm clock. But the Yun is awesome because it's got Wi-Fi and Linux, and so you can write some more advanced sketches. And so I'm using Tembu, which is the service that kind of wraps up all kinds of web APIs. It lets you talk to services like Gmail, Facebook, all these different web services. And I'm using it to read my Google Calendar. So I'm going to add a calendar event, and I'll just do this on the side here. And I'm going to add a calendar event to wake up at 9 a.m. So the alarm clock, it should set itself based on the time that I have for my earliest meeting. So if I click this refresh, then that's going to force it to go to Tembu and figure out what my calendar looks like. And we should see that it adds a new event here in a second. Okay, so it just updated. As you can see, alarm 8 a.m. And the cool thing is, so you can configure it and say, if I have a meeting at 9 a.m., then I should wake up an hour before that, or some fixed amount of time. And it'll go behind the scenes every hour or so and just check and see when's your earliest meeting. And you can block out like a window of time to say, okay, don't make an alarm after 11 a.m. or something like that. So that's one little feature that it has. And then the second thing is, you can send it an email, and so you can define a keyword in an email subject. So it'll also check my Gmail inbox. And if I get an email that says wake up or alert or some special keyword, like maybe someone needs to get a hold of me, it can actually set off the alarm. And I didn't really mention it, but this is just a USB speaker that it's connected to the Yun, so that it can play a little MP3 that has an alarm. So I'll send myself an email. So I just sent it, and I'll force it to refresh again, and we should see the alarm go off hopefully once it refreshes. Almost there. Oh, there we go. So I don't know if you can hear the alarms going off.
Wow, you have an MP3 of the classic alarm sound.
Oh yeah, yep, super annoying. You could set it to something else if you want, and if you just press that, then it turns it off. And so yeah, that's kind of the project here. It's pretty simple. It just uses the Yun. A bunch of Python scripts power this, and little TFT LCD, and you basically make it a smart alarm clock. And then also, of course, real quick, there's the cat.
Whoa, that's cute.
Oh, wow.
Oh, he's sleeping in a box.
The cat did not want to wake up.
Yeah, that's true. The alarm doesn't work on her.
It's convenient because it's self-storage.
Yeah, right.
You can breed cats like that in Manhattan that just put themselves into a small cubby hole, so you don't have to store them.
Yeah,
exactly.
This is the classic. If it fits, I sit.
Yeah.
All right.
That's a classic. That's your cat's box. Is that like a DigiKey box or something, or a mouse box?
I think it was like a Newegg box, something like that. Yeah, no, it was something I found out early on that you have to have, because if you don't do this, she'll sit on whatever you're working on, or become a bit of a nuisance. So it's a cat trap.
You got an interesting cat there. All right.
Okay.
Thank you for the update, Tony.
Next up, Young Pedro from Adafruit South. Hey guys, what you working on this week?
Please unmute.
Hey guys, sorry about that.
What you working on?
What's it, guys? Getting ready for another 3D Thursday tomorrow, jam-packed with all the 3D news stories we find around the web, design tips, and our weekly video. In the back, we got a future project printing out, and beta testing, a couple new products you may have in the store. Some very cool flexible.
Oh yeah, that's the
The
flex plate.
No, yeah, flexi plate. But for a feature project, this tiny little thing is what is holding all of this stuff together. It's pretty cool. It's flex dual printed. But this week, we'll be looking at
The preview.
A MIDI controller using the UNS library. Yeah,
cool.
it's one trellis and 4 potentiometers, and it makes funky sounds when you have it hooked up to any MIDI software.
And you got it working with the iPad or iPhone using the Camera Connect kit. It actually does USB MIDI as well, which is kind of cool.
Yeah, it's pretty awesome. So it could be pretty mobile in that sense. That yeah, you could be around, like maybe at a club or somewhere like a bus station or something.
a quick sketch.
Yeah, you can write a quick sketch on music.
The only downside to that, of course, is that they have not released a Lightning Bolt 2.
Oh, right. So you have to
both of these and spend like what, $60 on each one. So you gotta get the 30 pin that has the USB.
The adapter costs more than the actual trellis, as you know.
Yay, Apple. Okay, cool. Yeah, the 12th Lab, you'll have a video, and
Yeah, and tonight on Ask an Engineer, we're going to have the 3D Thursday video that just released last week.
the TAS
conversion.
the 1.75 millimeter TAS conversion project. So you guys have a lot of stuff going on.
And very soon, you heard it here first, a new live show with Adafruit.
What?
3D Hangouts coming soon in August.
Wow.
Yes,
That's right.
In the show, we're going to talk about how we build all this crazy stuff, take it step by step, a bunch of design, run you through CAD, printing, troubleshooting techniques, and all that.
Yeah.
As happens in this 3D printing world.
I love jazz.
Yeah, so stay tuned for that.
Okay.
All right. Well, thank you so much, guys.
So if you like this and you want a half an hour of this or whatever
That's
it's going to be, it's coming up.
You can watch things actually 3D print before your eyes.
It'll be, you can watch it while you're 3D printing something because you're like, oh, I'm going to wait around for half an hour to print my money.
Fails live.
Yeah. All right.
All right, thank you. Next up, Scott.
Next up is Scott. Hey, Scott. Welcome back to Show and Tell. Show us your project.
How you doing? Can you hear me?
Yay.
So I have a Davis weather station which wirelessly sends the data to a console, and I wanted to send the data up to Weather Underground. They have this whole network of personal weather stations that you can upload weather data that's from the weather station on your roof. So I built this little project where I have a Motino, which is basically an Uno with a radio transceiver on it, and a Ethernet module. It's got a WIZnet Ethernet module, and this is your BMP 180 breakout board. So this receives all of the data and then sends it up to Weather Underground in real time, which is nice.
Nice.
And there's this guy, his name is Decay, who put a lot of time over the last couple of years in reverse engineering all the Davis wireless protocol and all the serial communication, everything that went on. So I was able to use his library to get this working. And it works pretty good. You know, I did have one weird problem with the Ethernet library. It didn't work when I tried to set the IP for static. I had to use the DHCP. It would just come up 0, which is kind of weird. And I did want to use your CC3000, but it ended up using too much memory on the Uno. Yeah. I guess the wired regular Ethernet library uses less memory than the wireless.
There's a lot, because with wireless, there's just so much more stack level stuff going on. We've actually pared down the library quite a bit. It went down like 3 or 4K, but it's tough to fit in Uno. I mean, like, there's not a lot of space.
Yeah, I think this project compiled with your library for the CC3000 about 40K bytes or 41.
Oh, too many bytes!
Way too many. It wasn't even close. So
right.
I'm sure I could do it on a Mega if I wanted to.
All right, here we go. I'll go to Mega. Our library is Mega compatible. Okay, thank you so much, Scott.
Okay, Scott, don't forget email.
I've got everything on GitHub, and I put the link when I posted to join the Hangout tonight. So if anyone wants to see all the project files and the board files for the little PCB I made, it's all up there. So anyone wants to
Thank you so much.
Thank you so much. And as always, email support@adafruit.com, and you get an as seen on the Show and Tell sticker.
It's vinyl, so you can put it on your weather station. It will survive.
Sort of weather resistant. All right, next up is Trixie Bella.
Trixie Bella.
Trixie Bella, hello. How are you?
Whoa. Hey.
I'll unmute you and. Oops.
Wait.
Are you gone?
Hello?
You're gone. Hello.
Hey, can you hear me?
Yeah. All right. Show us your project.
Alright, having a little technical difficulties at the moment, but the idea is these NeoPixels right here are sound reactive to the board underneath.
Okay.
For some reason, at the moment, they're just not turning on.
Live demos.
The dog probably ate them. You can
Well,
always blame the dog.
What we can do is we can come back to you at the end, or you can just come back next week if you want.
Yeah, I'll probably just come back next week.
Okay. We'll hang out and enjoy the show. And
You know, I have a comfy couch, so
yeah,
I'll just sit on the
this
couch.
is exactly the right way to watch show and tell.
Trixie Bella, comfy couch.
Okay, and
Please
let's see.
have your comfy couch. Will is next.
Next up is Will. Hey, Will.
Hey guys, can you hear me all right?
Hello.
Yep, you sound great.
Okay, cool. So this is my project. It's a little box that I call the Streamliner. It's a hardware controller for digital audio workstations, audio recording software. That's basically, it's hardware control with a little bit of automation built in, but it can control two different bits of audio software running on two separate computers simultaneously.
Huh.
I work as a classical sound engineer, and we had one session where we needed to run one computer running Logic and another running a slightly more specialist classical recording bit of software called Sadie. We needed to get some MIDI in, so we had to use Logic. So I've got a quick little video, if I can make screen share work, just sort of showing off the two computers running at the same time, and I'll try and sort of narrate over it and see how that goes. So can you see that all right?
Yeah.
Yeah.
Okay, so this is obviously Logic, and it seems to be a little bit laggy, this video, which is not ideal, but that's our other bit of software. That is the box. If you squint when it turns on, you'll see it says BMP, or as best it can on a 7-segment display, which is the name of the company I built it for. Which is always a nice little personal touch. So it's renamed some stuff to make sure that all the numbers are consistent between the two systems. And actually, this video is really, really laggy, so I might just show it in real time. But it's set both systems off recording there. So I've got a single system with me here, and I will just try and show it on that rather than on both. Because it's rather early in the morning here, I didn't fancy camping out in the office with the other system, so I'll just show it.
It's a nice case. I like the slanted case style.
Yeah, it took us a while to find it, and we actually ended up buying it from a place in Turkey, which meant it cost about 3 times as much in shipping as the case, but it was really quite nice. So if I press that record button, you can see that Logic has just dropped into record, and press it again, and it will stop. So the middle button, the other two buttons are basically things that we find we're doing quite a lot in sessions, but are slightly different processes on the two computers, and sort of automating it saves a lot of hassle. So if you have press record and you find that actually the musicians are having a discussion or asking questions or whatever, rather than stopping and having to write that take off, you can press the middle button, which will retake it, and it deletes that bit of audio that you just did, brings the number back down 1, and means that you can then do take 3 again without any issues, and it will just start recording again. You can even press it without having stopped the recording, and it will deal with it all for you. The other one is a reel change button. The name harkens back to when you actually had to change reels of tape every time. So we record in sort of CD lengths, so we can really easily just burn a CD for whoever it is that needs to listen to the raw takes. And so basically pressing that button will save the project, do a save as under the new reel name, delete all the audio that's in there, and just sort of set it up so all your settings are there and that everything's good. So hopefully, if I press that button, in a moment you'll start seeing some stuff go on Logic. Sort of a few dialog boxes opening, typing in the name automatically, saving it there, and then deleting that and resetting the name. And now we're good to go on take
34.
Fancy. This is cool.
You made your own
This is like-
custom controller. This is a future.
This, watch out that you don't replace yourself.
Well, that's what we're worried about.
Because this already seems like it's more capable than many sound engineers. No, that's just mean. That was mean. But this is an excellent job. Good work. It's so
Very cool.
And this is what like doing Arduino and automation is all about. It's like you don't want to sit there and be like, take number 58. Wait, let me save the file as, and then you forget and whatever.
Yeah.
So thank you for showing your project, and I love the big 7 segments. That's always so cool.
The only thing missing on that is an as seen on the show and tell sticker, so you get one of those now.
Going back.
Thanks,
Yeah, Ben. Thank you so much, Will.
Okay, next
Okay,
up
we're gonna
is
people too.
Dustin. Dustin, I see your hat.
Wait, Roberto.
Dustin's hat was going off.
Oh, you just want to show Dustin's hat?
Yeah.
Yeah, it's a nice hat.
No, it's Dustin. Roberto, then
Dustin,
Adam.
Roberto,
Yeah.
and then Adam.
Yeah.
Sorry.
All right, Dustin, show us your project.
I followed Becky's tutorial. It's her hat, but I made it say the Make logo.
Oh, that's
cool.
great.
And
See,
I worked-
all our tutorials work, by the way, everyone. You can actually use them.
Maker Fair Kansas City a couple weeks ago. And so I have the cool hat. Now I made the glasses.
All right. Wow.
Oh, man.
They're the 1.2-inch LED backpacks.
Those are so cool.
Thank you.
You're going to be like the most popular person on New Year's for sure. You're going to be walking around with that, and everyone's going to be totally freaking out.
The glasses I got actually at My Nerd booth at Maker Fair in Kansas City. And so I'm repurposing them, and I can see out the bottom just fine.
Yeah.
And so I got the glasses, I got the hat. I'm ready to party.
You are a party. You are the party.
Oh, look at the smiley faces.
Yeah, the little smiley faces.
All right.
Okay, thank
Excellent.
you.
That's it. Send us a note to support@adafruit.com, and the hat gets an as seen on the show and tell sticker, so when you're walking around, people can know it was on the show and tell.
I
All
can't
right.
wait till we see like Kanye wearing this at a concert, because like you know he will.
Yeah.
I want to wear the hat to a concert just to see how well it works.
Yeah.
It probably works real well. I mean, like even if it doesn't work, it's just blinking.
When we were watching Becky's talk at the Hope conference, someone behind us said, "Hey, can you turn down your hat?" Because I had the messaging hat, and it said Hope. So that was kind of neat. In the future, people will ask you to turn
off your hat.
the brightness of your
The
hat.
hat's too loud.
All right, Roberto, how are you? Welcome back to Show and Tell. Yeah, you're a little scratchy, but we can kind of hear you.
Okay, what's going on is that instead of being in Texas like I normally am, I'm over here in a conference that my company sent me to.
Yay, company conference.
Things actually, the first one is I wanted to pimp out my name badge, and so I took out the medium LED on a backlight.
Oh, yeah.
And so I soldered on a computer's coin cell battery holder, and so I can make it reusable. And in the middle is just a magnet, and I put another coin cell as the backing. And so that's the first one. The second one is running on a Raspberry Pi. I don't know if you can see it on that screen there. I'm not able to demo it on a Raspberry Pi, but I just want to show that it runs. I'm missing the microphone to demo it because my USB microphone is back in Texas. But so the program that I want is similar to the other gentleman's, where he's doing stuff with recording stuff and playing it back. But to demo it, I want to do a parody of the beat track from one of my favorite movies from the 80s, which was Electric Boogaloo. And so on the screen, you'll see that I have an output directory where it's going to save the sound recordings to a record button, the format that I want to record it to, a stop button, and down here is where you're going to see the recordings. So let me make a quick, let me do that quick demo. And I hope the audio is good, because otherwise it won't work. Okay, here we go. All right, that's the first part, and I can play it back.
Yeah, we can hear it.
All right, that's loop. Okay, so hold on, let me get the second track. Oh, I'm sorry, I left a big part out. The inspiration from this comes from that device that Reggie Watts uses to do.
Oh yeah.
To do his whatever that awesome stuff that he does.
Yeah. No, I
Reggie
know.
Watts,
No,
it's a thing that makes him do the weird
whatever
voice
it's called. It's now called the Reggie Watts machine because it's that
No,
good.
I will not call it that. It's a parody of that. So okay, so I have umdada. Hold on. Umdodo. Okay, so that's what I just recorded. Okay, so now I just want to put a little effect in, and I'll loop it all and play it together. Are y'all still seeing my screen share?
Yeah.
Yeah, yeah. You're playing and looping and removing and.
Here's my effect. Whoop whoop. Okay, so now I'm gonna play everything all together in loop.
And you're doing this in your hotel room at a conference, right?
Yeah, I'm at a conference right now, and I'm missing the the social hour. But I'd rather be here than there because nobody's making stuff over there. They're all trying to sell stuff.
Yeah, I was gonna say when Lord and I are at conferences during the social hour, we tend to escape to try to go work on projects.
The problem is
too.
everyone is chasing after us, being like, "Hey, I have this idea for this project I want you to build right now in your hotel room."
Yeah.
The Reggie Watts machine. We could put on Kickstarter.
Excellent.
So, anyways,
all right, Roberta, that's
awesome.
That's excellent. You get a hotel hacks sticker if we have.
I want
on the
you and Rob to
software.
work together and make the Reggie Watts machine. Okay, by next week. Homework assignment.
I just want to mention that normally I would have already posted the code for this, but there is a dependency on the one software bit that I haven't published yet, but eventually I'm going to put it on GitHub.
Okay, well you're also at a hotel right now, so it's understandable.
Yeah, I mean, like you're lucky you have internet.
Yeah.
I mean, usually you have to pay like $50.
All right, and next up is Adam. Hey Adam, how's it going? Show us your project.
Can you guys hear me okay?
Yeah, you sound great.
All right, so my project is a home security and monitoring system. Its job is to just publish real-time notifications to my Android phone via the Google Cloud messaging service. So I chose GSM service because it handles all aspects of queuing and messages to my Android device. It's completely free, there's no quotas. The actual application itself is running on a Raspberry Pi, so I wrote this in Flask. Flask is just a micro framework for Python. I'm utilizing RESTful Web, request dispatching, and then it's backed by a SQLite database using SQL Alchemy as my object relational mapper. So I'm going to do a screen share here so you guys can see.
You got all the cool frameworks.
Yeah. So let me just share my screen here.
You wrote it in Flash, and I was like,
no,
my God, everything was so cool until you wrote it in Flash.
Hey,
Flask.
Hey, Flash wasn't the worst thing.
Sorry.
Can you guys see my screen okay?
Yeah, we can see that.
Okay, so this is a PCB that I made. So this is in my basement. So I basically took my existing alarm panel, just ripped out the circuit board that was in there, and then kept all of the sensors. So I have motion detectors, keypads, alarm siren, smoke detectors, door sensors, all wired to this PCB. So this is there's an Arduino sitting underneath here. So this is just an Arduino Uno shield that I made. It's a relay shield. And then this thing's connected to my Raspberry Pi via a USB cable. So anytime any of these sensors trip, what happens is it writes out just data, just bytes across that USB serial cable to my Raspberry Pi, and then the Raspberry Pi is connected to an Ethernet cable, which is able to get out of on the internet, publish events to the Google Cloud messaging service, and then eventually those will get routed to my phone. So here's a close-up of the board. You can see the left-hand side here is filled with sensors that I have plugged in, and then the right-hand side, I left myself room to expand, add more motion detectors in the future. And I'm kind of maxed at 19 pins right now with this Arduino Uno, so eventually if I find the need for more sensors or more just anything I want to plug into this board, I'll have to go with something like an Arduino Mega instead of the Uno here. But for now, this is kind of meeting my needs. Here's a picture of the keypad that I made. So this is using the Adafruit character LCD display, and then I have a keypad hooked up to it. And there's a thin speaker with a toggle switch. And the purpose of the toggle switch is to kill power to this keypad because there's another Arduino sitting behind here. So anytime we need to upload code or anything, I didn't want to have to take this thing apart or take it out of my wall. So I have these pinouts that I can plug my laptop in over the USB cable and just upload new code to it without having to take this thing apart or disassemble it, which is kind of nice.
Yeah.
Okay, disarmed.
Right. So here's a picture of what's on my Android phone. So this is the web application that's running on Flask, and this is just displayed on my Android phone here. So this is the keypad, the soft keypad for it, so I can arm the system away, arm it stay, disarm it, and then I'll receive those notifications to my phone. And there's also, I built in some event pages so you can see different type of events. I have a full user profile so I can click and register for different types of notifications that'll all get sent to my phone. You can also set these up to email you if you don't want the notification on your phone. And then I also added an administrative user interface so I can go in here and map pins to that Arduino board that's in the basement. So when I add new sensors to this board, I don't have to change any code on the Arduino side. I can just go out to this administrative console, which is the Flask application on that Raspberry Pi, and I can configure those pins. So anytime a pin, I can say whenever pin 3 goes low, that means that my garage door closed, or whenever pin 3 goes high, that means my garage door opened. I also have connected to this system a doorbell. So I replaced my doorbell with a double pole single throw switch. This is just a toggle switch, and I did a double pole because I needed something to run the AC current through for my existing doorbell chimes. And then the second pole of this is connected to another Raspberry Pi, which is on the inside of the house here. So this is the Adafruit TFT touchscreen display. And I basically have, on these GPIOs, I wired in a doorbell sensor so I can pick up when somebody rings the doorbell. And then on the outside of the house here is a camera, so whenever they ring the doorbell, what happens is this Raspberry Pi takes their picture in the basement, which then looks up what devices are registered for a front doorbell press, and then sends that picture of who's at your door to your Android phone. So those are all the components to it. I'm actually going to go through a demo now. So let me stop sharing here so you guys can see.
What's cool is there's so much electronics attached to your house that if I was a burglar, I'd actually be scared of breaking into your house. Because like most people, like they don't know what all this stuff is, so they'll see the control panel and they'll be like, oh my god, it's a bomb. I have to get out of here.
Well, let's see a demo before
demo.
we run out of time, because this is really exciting.
I have my phone here, so I'm going to walk out to the front door. We'll hold you guys up to the camera here and ring the doorbell.
All right. I think this is the first ever live burglary on Show and Tell. And he got in.
So here in a second, I don't know if you heard the second doorbell. So that was on my phone. So that sent a notification to my phone here. And you can see it says ding dong, and there's a little Android notification that pops up.
Yeah.
So when you click on that notification, what that's going to do is it's going to load the Flask application that's running in the basement here. Let me see if I can zoom in so you guys can see it. And then it has the picture of...
Wow.
There we are.
This is like the smartest doorbell. You're about to be bought by Google for $1 million.
And then the second thing I was going to demo for you guys was the actual the alarm itself. So let me pull up here on the display. So this is the soft keypad that I was showing you guys a picture of.
Yeah.
I'm going to enter in my PIN here. The system's currently disarmed. So let's arm it in stay mode. And so you can see it's sending a request, and then it's going to send another notification to my phone letting me know that the alarm system changed from disarm to arm stay. So we're in arm stay mode here on the phone. So what I'm going to do is I'm going to go open up the front door. So if you guys have headsets on or your speakers turned up, you might want to turn them down because this is going to be kind of loud. Okay. And then I'll get
we're ready.
On my phone and I'll deactivate it, and the alarm siren is going to go off here.
I think I see the speaker for the alarm.
There it is. Woo! Okay. Disarm!
Okay. All right, type in the code.
All right.
Okay.
I punched in the code, and then I got the siren to turn off, and then I got another notification that my system is disarmed.
You have the safest
house. Thank Adam, that was a fantastic demo. If you're ever interested in writing it up on the Adafruit Learn system, let us know. And you did an excellent job with that. If you ever wanted to add a phona to make it an actual phone call, let us know. We'll donate that to your home security project. Okay, just email support@adafruit.com for you. Just put attention Phil, and I'll take a look at that if you want to take us up on that offer. And everyone, these are fantastic projects. Thank you, Will. Thank you, Trixbella. Thank you, Scott. Thank you, Roberto. Thank you, Noah and Pedro. Thank you, Dustin. And thank you, Adam. Your house is safe and secure. All right. Bye, everybody. We'll see you on...
Tony's gone, but he was here.
Yeah, he was here
Thanks,
a second ago. We'll see everybody on Ask an Engineer in like 1 minute. All right. That was great.
Okay, gotta go.